right, so today we're going to work on looking at systems of equations to analyze graphs. So we're going to be looking at some word problems, we're going to be graphing, and then trying to figure out what the models mean. Okay, what the models mean. So let's start with determining whether or not these are solutions. So if you remember, the easiest way to determine if a point is a solution is to substitute and see if the solution is true or false. So I'm going to go ahead and start with my first solution of negative 1, 4. And I'm going to substitute into my first equation. The x comes first, the y comes second. So I see that I have negative 1 plus 4. Well, that's 3. So 3 equals 3. So I see that one is true. Okay, that is a true statement. Well, what happens if I check the second one? So I have negative 1, 4. Again, 8 times negative 1, that's negative 8, plus 4, well, that's negative 4, negative 4. So I see that one is also true. So I know this one is true and true, which means it is a solution. Okay, it is a solution. Let's see what happens with the other one. So I'm going to substitute in my negative 2, 5. Well, negative 2 plus 5 is 3 equals 3, so that one's true. Well, I wonder what happens with the next one. So 8 times negative 2 plus my 5, negative 4. So this is negative 16 plus 5. Well, that's negative 11. Does that equal negative 4? Nope, that doesn't. So you can see how this one has a true and a false. So this one is not a solution. Okay, we have to have true, true to be a solution. Okay, let's take a look at this taxi cab problem. And we have looked at this cab problem before in some cases. We've used it a few times to kind of do some compare and contrast. So if you remember, the point of intersection is where things are equal, okay? Where things are equal. So in this case, since our intersection is here, and that is 3, 8, we have miles and we have money. So that means that the same price at 3 miles, and it's going to cost $8. So no matter which cab I ride if I'm going to go 3 miles, it's going to cost the same price. It doesn't matter. But there is a difference when I go more than 3 miles or less than 3 miles. So I'm really kind of splitting my graph into two pieces. I'm going to the right and I'm going to the left. So let's take a look at going to the left first. So if I go to the left and I go to the 1 mile, I see that my yellow line is about 3.5 and my blue line is about 6. Well, obviously the yellow one is cheaper. Well, where does it start to be cheaper? So we are going to use symbols like less than, which is pointing to the left, and greater than, which is pointing to the right, okay, to kind of explain when I should be riding the yellow cab. Well, the intersection point has to play into this, okay? It has to. So it's super important that we use that as our bouncing off point. So if I travel less than 3 miles, because I'm going to the left, that means I'm talking about less than, I want the yellow cab. So if I go on the other side, I see that if I start at 6 miles, here's the blue and there's the yellow. So the blue is cheaper. So if I am going to travel greater than 3 miles, I want to call the blue cab or ride the blue cab. It'll save me money. So again, that intersection point is the point of that really matters. That's where things are the same, but that also tells us where things change. Okay, so let's see if we can come up with these equations and get some answers. And we're going to look at these graphically to kind of see what is going on, okay? So Pedro was saving quarters and dimes to buy a new skateboard. After months of saving, he emptied the jar and counted the money. There were 561 coins, and the bottle had a total of $107.85. Well, what are my two variables? What are the two things that I am saving? Well, I see that I have quarters and I have dimes. So quarters is going to be my X value, and dimes is going to be my Y value. So I have two things here. I have money and I have a total of coins. So let's think about if I am going to be talking about money, what would my equation be? So I need something X plus something Y is equal to $107.85. What do I know about quarters? If it's money, oh yeah, that's right. They're 0.25. And dimes are 0.10 or 10 cents. So now I have my first equation, and that's going to be the money one. Okay, what would the second equation be? So something X plus something Y equals 561. Well, do I know how many quarters I have? Do I know how many dimes I have? No, they didn't give me any other numbers. So if they gave me no other numbers and no other information, then these are just 1x plus 1y equals 561 because I don't know how many dimes or quarters I have. Okay, I just don't know. Okay, so we're going to solve this graphically, and I went ahead and did that for us. And we need to figure out the number of coins, and we already know our total money. The total money is 107.85. Okay, so we've got our total coins and we've got our money. So let's take a look at our graph here and try to figure out what's going on. Okay, so here's my dimes and quarters, and there are multiple solutions to this. Okay, there are multiple solutions to this, but the equal point, okay, the equal point or my solution is 345 to 16. Well, what does that mean? What was my X? What was my Y? Well, my X was my quarters and my Y were my dimes. So I have 345 quarters and 216 dimes. Okay, 216 dimes. So that is my solution. Okay, that is my solution. So that's on a very simple level of looking at a model of an equation. Okay, let's take a look at a second type of word problem. So we did a standard form, that's ax plus by equals c. What's the second type of linear word problems? Yeah, it's slope-intercept form. So it's y equals mx plus b, okay? Where we have a slope and we have a constant, where the b happens once. All right, let's look at this one and let's see if we can figure out what's going on here. Okay, so I have McDonald's and I have Kentucky Fried Chicken. And it says Cole decides to call for some fast food delivery. If he chooses McDonald's, the delivery fee is $5 and each hamburger costs $1.50. For Kentucky Fried Chicken, there's no delivery fee, but the chicken sandwich costs $2.5. If the cost of the two options are the same, how many hamburgers did he buy? So we're looking for how many hamburgers he bought if the two options are the same. Okay, so let's see if we can come up with what's going on with our problem. So do I really have an X and a Y? Yeah, I do. My Y is my total cost. My Y is my total cost, and yellow is not going to work for that. The Y is the total money this time. And the X has to do with sandwiches. Okay, it has to do with sandwiches. So I'm looking for the number of sandwiches I can buy. Okay, the number of sandwiches I can buy. All right, now let's write our equation for McDonald's. So I see that there's just a delivery fee of $5. Well, that's not going to change. No matter how much I order, that's not going to change. So the $5, that's my B, which means the 1.5 has to be my M. So my equation for McDonald's is 1.5x plus 5. Okay, what about Kentucky Fried Chicken? It says there's no delivery fee. Well, that would mean that the B is 0 because they don't charge me any extra. But my M is 2.5. So I have Y equals 2.5x plus 0. So I've got my two equations. Now let's go ahead and look at the picture. Okay, so here's my solution. I have 5 and 12.5. 5 and 12.5. So I can buy 5 sandwiches. Okay, I can buy 5 sandwiches for $12.50 from either place. Okay, so here it's the same. Okay, five sandwiches are going to cost $12.50. Doesn't make a difference who I buy them from. I'm going to get 5 sandwiches. But there is a difference in terms of cost and how many sandwiches I can get depending on where I go from that point. So let's go over and let's say I want 3 sandwiches. There's 3 people in my household and I want 3 sandwiches. If I go up, I see that McDonald's is going to cost me, let's see, that's 5, 6, 7, looks like about $7.50. And KFC is going to cost me about $9.50. So who's the better deal? Yeah, the $7.50 is a better deal. So if I want 3 sandwiches, it looks like I should probably purchase McDonald's. Well, where does that stop being the best deal? Well, let's go on the other side of our equilibrium point. Let's go up here to 7 sandwiches. So if I want 7 sandwiches, I see that the black line, which is Kentucky Fried Chicken, is about $15.50. But my McDonald's is up here at about $17.50. So who's the better deal? Yeah, Kentucky Fried Chicken is the better deal at that point. Okay, Kentucky Fried Chicken is the better deal. So how do I explain to somebody which one is the better deal? Again, it comes back to that intersection point. Okay, it comes back to that intersection point. So if I want less than 5 sandwiches, who should I buy from? Yeah, McDonald's. I should buy from McDonald's because that's where it's going to be cheaper. But if I need more than 5 sandwiches, who should I buy from? Yeah, KFC is going to be the better deal at that point. Okay. But if I need 5 sandwiches, who should I buy from? Yeah, it doesn't matter. If I want 5, it does not matter because it's exactly the same at 5. Okay, let's look at another one. Okay, the Bayplex Center 200, the Bayplex and the Center 200 rent their ice rink out to the community whenever possible. So Bayplex charges a flat rate of $20 plus $15 per hour. So I think those are important. So I'm going to go ahead and underline that. And I see a per there. That's important because per each and every, that kind of triggers that slope. And then it says the Center 200 charges $50 for a flat rate, but only asks for $10 per hour. So we have some different prices here. So what is the equation for Bayplex? Well, I see that the $20 is a flat rate. That means it's going to happen once. So I know my B is 20 and my 15 is my slope. So my first equation is y equals 15x plus 20. Okay, what's the second equation? Well, I see they charge $50 for a flat rate. So there's my B, but only $10 per hour for their ice rink. Okay, so there's my equation. Let's take a look at our graph and figure out what the intersection means. So here's my graph. Okay, here's my graph. Okay, so the intersection point is 6, 110. So what does that mean? What does that mean? What does the intersection point mean? So the 610, well, the 6 is my hours, and the 110 is money. So since it is it's the point of equilibrium, it's the center, both companies cost the same. If I'm going to rent for 6 hours, they're going to cost $110. It doesn't matter who I buy from at that point because it's going to cost $110. Okay, so remember, we have to look at more than or less than to try to figure out when we should be using the other two companies. Okay, there's a difference between the two companies. So we know that we've got the red one and we've got the blue one. And the red one is going to be our Bayplex. Okay, so the red is the Bayplex. So I'm going to mark that one as red. And the blue one is center. Okay, so let's take a look at our graph and let's try to figure out, and I know that we can't see the entire graph because these lines are pretty close together, but we still can analyze what's going on here. So if I look at more than 6 hours, okay, more than 6 hours, let's go up here to 7 hours or 6.5 hours. If I come up here, which line am I going to run into first? Yeah, I'm going to run into the blue line. So at 6.5 hours, the blue line is going to be cheaper. Okay, that means that's center. Well, what happens if I go the other way? What if I'm down here at 5 3/4? Yeah, I'm running into the red line. So the red line is cheaper if I'm on the other side of the 6 hours. Okay, so I'm looking at both directions. So when should I use center? Well, remember the words that we're looking at using: less than, or greater than, or more than. Those are things that kind of help us. So what do you think? When should I use the center? Yeah, so center should be when if I want to rent for more or greater than 6 hours, because that's my blue line. I want to rent for more or greater than 6 hours. How about Bayplex? It's going the other direction. So that would mean if I want to rent that typed in there, rent for less than 6 hours. Okay, if I want to rent for more than 6 hours or less than 6 hours. Everything comes back to that intersection point, okay? And if you're going to go to the right, that's more than. If you're going to go to the left, that's less than. And you have to figure out which line you run into first. Okay, so at this point, you're working on some practice problems. Reach out to us if you are struggling. It's a Desmos activity today. Remember, greater than, less than, greater than to the right, less than to the left. Have a good day.